Let's continue with the final review. For number 4, identify domain vertical asymptote line, horizontal asymptote, oblique asymptote, roots, y-intercept, and any holes in the rational function. For rational function, we have Dirac diagram. Use this diagram to figure out different properties of a rational function. For the domain, you need to make original function denominator not equal to 0. Before we go to domain, you have to factor rational function. X squared minus 49, that's x plus 7, x minus 7. Then x plus 6. We will make a denominator not equal to 0. That means this one not equal to 0. So we get the x not equal to negative 7, 7, and negative 6. For vertical asymptote line, it's a simplified rational function. Since we don't have a common factor to be reduced, therefore, original function and a simple function is the same for this rational function. So, for vertical asymptote line, your x equals negative 7, x equals 7, and x equals negative 6. Vertical asymptote line is an equation, so we write down this way. For horizontal asymptote line, you can do the limit, or you can just remember the rule. I prefer the limit. For limit, you got to use leading term. So check the leading term. Leading term to the top, that is a negative 3x. Denominator, look at the leading term. This is x for this factor. X again, x again. So we get the x to the third power. We do the limit as x approaches infinity of negative 3x over x third power. Then you reduce. You will get negative 3 over x squared. Then we plug infinity to this x. You will get 0. Therefore, for horizontal asymptote line, y equals 0. For oblique asymptote line, keywords is 1 more degree. Therefore, it's not available. For the roots, you will set up numerator equal to 0. Therefore, I do negative 3x equal to 0, x equal to 0. For the roots, you will get 0, 0. For y-intercept, you need to make f of 0. Now we need to plug in 0 to the function. F of 0 equals. That's negative 3 times 0. Since your numerator equals 0 already, and your denominator, it doesn't matter what is it, it will be 0. So y-intercept is 0, 0. No hole for this rational function because no common factor to be reduced. Now let's go to B. First of all, you need to factor the numerator. Ninja x, we got negative 6, negative 1 over 3 over 3. So we get negative 3, this is 2. Then reduce, you will get negative 1, 1. So we get the x minus 1 and 3x plus 2. Over x plus 5. For domain, you will make a denominator not equal to 0. That is x plus 5 not equal to 0. X not equal to negative 5. For vertical asymptote line, it will be the same because no common factor to be reduced. Original function and a simplified function are the same. For vertical asymptote line is x equals negative 5. For horizontal asymptote line, we need to do the limit. Limit as x approaches the infinity of leading term, that's 3x squared and over x. So 3x squared over x. You will get 3x over 1. Then we plug infinity to this x, you will get infinity. Means horizontal asymptote line is not available for this rational function. For oblique asymptote line, 1 more degree, which means your numerator has 1 more degree than the denominator. We do have oblique asymptote line for this rational function because of this x squared, here's x. You got to do synthetic division or long division. For this rational function, synthetic division is much easier. So remember, root in the corner, x plus 5 equal to 0, x equals negative 5. Then no missing power, so we have 3, negative 1, negative 2. Drop down this 3, negative 15, negative 16. Only do the first 2, that's enough. So we have x squared here, this is x. That means y equals 3x minus 16 will be the oblique asymptote line. For roots, we will make a numerator equal to 0, which means x equals 1 and negative 2 over 3. So we write down 1, 0 and a negative 2 over 3, 0. Y-intercept means we plug in f of 0 to this equation. So we plug in f of 0 equals, whenever you see x, then that will be 0. I can plug into this original one. Here's 0, 0, 0. Therefore, you get negative 2 over 5. So y-intercept is 0, negative 2 over 5. If you want to plug into this factored form, you will get the same answer. Since no common factor to be reduced, therefore, no whole for this rational function. Let's go to C. We still need to do the factoring for numerator and the denominator. For the numerator, we do ninja x. So we get negative 30 because 5 times negative 6. This is 7 over 5 over 5. For negative 30, you can get the 10 times negative 3. Reduce, you get 2 over 1. Then you put the x here, do the bottom up. You will get x plus 2 times 5x minus 3. For denominator, 24 over 4 over 4, you have 11. So you get 3, 8. Reduce 2, here's 1. Then put the x over here. You will get 4x plus 3, x plus 2. Then reduce. We'll get the simplified rational function that is 5x minus 3 over 4x plus 3. For the domain, original function, this will be original function. This is a simplified function. For original function, you make a denominator not equal to 0. Therefore, you will set up this 4x plus 3 times x plus 2 not equal to 0, which means x not equal to negative 3 over 4 and also negative 2. For vertical asymptote line, this is simplified function denominator equal to 0. This is a simplified function, and I just make a 4x plus 3 equal to 0, means x equals negative 3 over 4. For horizontal asymptote line, we still go to limit. You can only do domain by using original function. Rest of the properties, you can use a simplified function. Therefore, for limit, you will get limit as x approaches infinity of using these two, 5x over 4x. Reduce this x, you will get 5 over 4. So y equals 5 over 4. No oblique asymptote line, because for horizontal asymptote line and oblique asymptote line, the relationship is either or neither. Or you can use this diagram, say oblique asymptote line, you need 1 more degree. For roots, go to simplified function. Therefore, you will make a 5x minus 3 equal to 0. So x equals 3 over 5, which means 3 over 5, 0 will be the root. For y-intercept, that's f of 0. I'm still using the simplified one. So you get the 5 times 0 minus 3, 4 times 0 plus 3. So answer will be negative 1. For y-intercept, that's 0, negative 1. Since we reduce this common factor, therefore, we do have a whole for this rational function. We will make a common factor equal to 0. So x plus 2 equal to 0. X equals negative 2. Then I plug negative 2 to this simplified function. So we get the f of negative 2 equals 5 times negative 2 minus 3 over 4 times negative 2 plus 3. You will get 13 over 5. Therefore, the whole will be negative 2, 13 over 5. Now let's go to D. We will factor the denominator first. We got negative 7. This is a dose factoring. Therefore, we got the 5x plus 2, 5x minus 2, and x plus 1. For domain, you will make a denominator not equal to 0. Therefore, x not equal to negative 2 over 5. 2 over 5 and negative 1. For vertical asymptote line, since no common factor to be reduced, therefore, simplified function and original function are the same. You will get x equals negative 2 over 5, x equals 2 over 5, and x equals negative 1. For horizontal asymptote line, we will use this limit. So the limit as x approaches infinity of leading term, numerator negative 7. Look at the denominator. I have 25x squared times x. So we got 25x to the third power. You plug infinity to this x, you will get 0. So horizontal asymptote line is y equals 0. No oblique asymptote line. For roots, you will set up numerator equal to 0. Negative 7 never be 0. Therefore, no roots for this rational function. For y-intercept, I will plug in f of 0. You will get negative 7. This is a 0, so you get negative 4 times 1. Therefore, 0, 7 over 4 will be the y-intercept. No hold for this rational function. Now let's go to number 5. A solution of f of x equals this polynomial function is negative 3. Find the other two solutions. You are given quadratic formula to use. If you are given a solution, you got to use synthetic division. Here's the rule for synthetic division. Roots in the corner, no missing power. Then you do multiplication and add. Go down 1 degree each time. You are given the root, that's negative 3. No missing power. For this polynomial, there's no missing power. So we write down 5, 16, 1, negative 6. Drop down the first one. Multiplication, you get negative 15. Adding is 1. Multiply negative 3, adding negative 2. Multiply 6, adding is 0. For leading degree, this is x third power. So drop down, we go to x squared. Here's x. Now we need to solve this quadratic equation. 5x squared plus x minus 2 equal to 0. We cannot do ninja x. Therefore, we use the quadratic formula. We have a equals 5, b equals 1, c equals negative 2. Then we plug in 2 times 5. Negative b, that's negative 1 plus or minus square root. 1 squared minus 4 times 5 times negative 2. Therefore, we get denominator is 10, negative 1 plus or minus square root. 1 plus 40, so we got 41. You cannot simplify square root of 41. Therefore, this will be the solution. Now let's go to B. fx is a polynomial function. Given that x plus 1 and 2x minus 1 are factors of it, find all zeros. Since x plus 1 is a factor of this polynomial function, we can get the root x plus 1 equal to 0, x equals negative 1. For 2x minus 1, we put equal 0, x equals 1 half. Then we do synthetic division. We have negative 1. No missing power. 4, 3, 2, 1, x to the 0 power. This is good. So 6, 5, negative 6, negative 3, 2. Drop down this 6. Multiplication. We get negative 1 times 6 is negative 6. Adding negative 1. Multiply is 1. Adding is negative 5. Multiply is positive 5. So you get 2. Multiply is negative 2. We got 0. Then we go to 1 half. Going down, this is a 6. Multiply. 1 half means your 6 divided by 2. Therefore, we get 3. Adding is 2. Multiply is 1. Negative 4. Multiply is negative 2. We got 0. Since for the root, denominator is 2. Don't forget divided by 2 here. Therefore, you get 3, 1, negative 2. Then check the leading degree. We have x to the 4th power, x 3rd power, x squared. So this is a x squared plus 1x minus 2. Then we make 3x squared plus x minus 2 equal to 0. We can factor this. We do the ninja x. Negative 6, 1 over 3, 3. So we get 3, negative 2. Reduce, you get the 1 over 1. Then we put the x here. Bottom up, we get x plus 1 times 3x minus 2 equal to 0. Therefore, we get the x equals negative 1, and also we got x equals 2 over 3. All the zeros. This is a negative 1 is a x1, 1 half. We get a negative 1 again, then it's a 2 over 3. Therefore, you can write down x1 equals negative 1, x2 equals 1 half, x3 equals 2 over 3. For negative 1, that's a multiplicity of 2. 1 half is a multiplicity of 1. This is a multiplicity of 1.